Math 1143, Test 3, Review Sheet, Chapter 3 material. We're continuing with Section 3.6. In this one, number 4, an exponential function has the form y equals a times b to the x, where b is greater than 0 and b is not equal to 1. Keep in mind that the exponent x applies to b only, not to the number a. So if the graph of the function in the xy plane passes through the points 1, 6, and 324, find the values of a and b. Okay, so the ordered pair 1, 6 that the graph passes through, that indicates that when x equals 1, the y-coordinate is 6. So I'll just rewrite the function y equals a times b to the x. So when y equals, or I should say when x equals 1, y equals 6. So replace y with 6 and replace x with 1. So we get 6 equals a times b to the first, or just 6 equals a times b. Then the other point that the graph passes through is the ordered pair 324. So this time, when x equals 3, the y-coordinate is 24. So we can replace y with 24, set that equal to a times b to the third this time. Okay, there's more than one way to go about determining what a and b are. One way is to solve each of the two equations for a. So if I solve this equation for a, I get a equals 6 divided by b. And if I solve the second equation for a, I get a equals 24 divided by b to the third. And then by substitution, I have 6 over b equals 24 over b to the third. And this equation is equivalent to b to the third over b equals 24 over 6. b to the third over b is b to the second, and 24 divided by 6 is 4. And since b has to be a positive number, b is positive 2. And then we can use either of these two equations to determine what a is, now that we know what b is. So I'll just use the easiest one, a equals 6 divided by 2, which is 3. Okay, so our function, if we write it out, a times b to the x, it's y equals 3 times 2 to the x. That's our function. And then in part 5, a similar type of exercise, but this time we have a exponentially decreasing function. So y equals a times b to the x, b is greater than 0, but b is not equal to 1. And the graph of this function passes through the points 2, 18 and 4, 2. Okay, so y equals a times b to the x again, but this time when x is 2, y is 18. So we can replace y with 18 and x with 2. So we get 18 equals a times b to the second. And then the other point that the graph passes through, when x is 4, the y-coordinate is 2. So we can this time replace y with 2. So 2 equals a times b to the fourth. And now we just use these two equations and solve for a and b. We can do what we did last time. We can solve each equation for a. Solve the top equation for a, we get a equals 18 divided by b to the second. Solve the bottom equation for a, we get a equals 2 divided by b to the fourth. And so 18 over b to the second equals 2 over b to the fourth. And this is equivalent to b to the fourth over b to the second, equals 2 over 18, or b to the second equals 1/9. And since b has to be positive, we'll take the positive square root of 1/9, which is 1/3. Okay, and now that we know what b is, we can use either of those equations to determine what a is. So we'll take the easy way out. A is equal to 2 divided by 1/3 to the 4th. But 1/3 to the 4th is just 1 over 81. Okay, so A is equal to 2 over 1 divided by 81. And 2 divided by 1 over 81 is equal to 162. Okay, so our function then is y equals 162 times 1/3 to the x. And if you want to verify that these are the right numbers, you can just evaluate this function when x is 2, replace x with 2 and do the arithmetic. And sure enough, you get 18, and then use the other ordered pair. When x is 4, 1/3 to the 4th is 1 over 81, and 162 divided by 81 is 2. So everything checks out on that one. Okay, there are some miscellaneous problems on the test 3 review sheet. So these are just some basic properties of exponents. If you have 3 raised to the exponent square root of 2, and if that entire term is raised to the exponent square root of 2, then we multiply the exponents. So we get 3 raised to the square root of 2 times the square root of 2. But the square root of 2 times the square root of 2 is 2, so we get 3 to the second, and 3 to the second is 9. In the next example, we have 5 raised to the exponent 2 plus e, and we're multiplying that by 5 raised to the exponent 1 minus e. So we're multiplying 2 terms that have the same base, so what we do is we add the exponents. So it's 5 to the 2 plus e plus 1 minus e. And then do the arithmetic. We get 5 to the 3rd. The plus e and the minus e add up to 0, and then 2 plus 1 is 3. And then 5 to the 3rd, that's just 5 times 5 times 5, which is 125. Okay, the next example, we have 2 raised to the x plus 9 in the numerator, divided by 2 to the x plus 1 in the denominator. So this time, if the base numbers are the same, so we can write this as 2 to the x plus 9 from the numerator and minus the exponent from the denominator. So if we subtract the entire binomial x plus 1, it's minus x minus 1. And then we get 2 to the 8th. Let's see, well, what's 2 to the 8th? I know that 2 to the 6th is 64, 2 to the 7th is 128, and so 2 to the 8th is 256. Okay, in the next couple of problems, number 2, we have parts A and B. Find the inverse functions and the domains and ranges. Let's find the domain of this first. Remember, arguments of logarithms have to be positive, so 2x minus 5 is greater than 0. That means 2x is greater than 5, and so x is greater than 5/2. So the domain of the logarithmic function is, in interval notation, is parenthesis 5/2 comma infinity. That's the domain. Since the argument is just linear, the range is all real numbers from negative infinity to positive infinity. And then we'll find the inverse. So y equals log base 7 of 2x minus 5. In the next step, interchange x and y, replace y with x, and replace x with y. And then we solve for y. So we can convert this logarithmic equation into its exponential equation equivalent. 7 raised to the power x equals 2y minus 5. So I'll write 2y minus 5 equals 7 raised to the exponent x. Then we add 5 to both sides, so we get 2y equals 7 to the power x plus 5. And then divide everything by 2, y equals 7 to the x plus 5, all divided by 2. Okay, so what do we know about the domain and range of the inverse? Well, we know the domain of the inverse is the same as the range of this function. So, okay, so we'll write the domain of this inverse is all real numbers, and the range is from 5/2 to infinity. Okay, so we know that because we can identify what the horizontal asymptote is. It's y equals 5/2. Okay, the next problem, y equals 2 to the x plus 1 minus 3. The domain of this function is all real numbers. All real numbers, negative infinity to positive infinity. And we can tell by looking that the range is from -3 to infinity because of this minus 3, that the horizontal asymptote is the line y equals -3. So the range is from -3 to infinity. Okay, let's find the inverse. So write y equals 2 to the x plus 1 and then minus 3. Then interchange x and y. We get x equals 2 to the y plus 1 minus 3. Now we solve this for y. So add 3 to both sides. X plus 3 equals 2 to the y plus 1. And we want to solve for y, but we see that y plus 1 is in the exponent. So we'll convert this to its logarithmic equivalent. The exponent y plus 1 is equal to the base 2 logarithm of x plus 3. And now we're just one step away from the inverse. Y equals log base 2 of x plus 3 minus 1. Okay, so the domain of this function is the same as the range of its inverse, but we can tell by looking, the argument of this logarithm is x plus 3, and x plus 3 has to be greater than 0, which means x has to be greater than -3. So the domain of this logarithmic function in interval notation is from -3 to infinity, which is the same as the range of its inverse. And the range of this logarithmic function is all real numbers. Okay, so that's all we'll do on this one.